So in the previous session, we have found the A inverse using the rank method. And what I wanted to say to you that since in the augmented matrix, you are calculating along with the identity of matrix along with the matrix given, and you want to interchange the position, you want to make AI as IB. So actually the identity matrix is shifting its position. Okay. So if your row operation is correct, then in that particular case, the actual inverse of the matrix will be obtained. But if you have made any mistakes in row operation, then in that case, identity matrix will not appear. That is the important thing. And if you have any doubt in your mind, in that case, you have the tool to check whether your calculation is right or wrong by multiplying the matrix A by matrix B and by checking whether identity matrix is coming on the right hand side or not. Okay, so that is the thing uh, I wanted to discuss with you. Now, one important point I want to make is that the important point is, if capital A is an n by n matrix, if capital A is an n by n matrix that is not invertible, that is not invertible, then any attempt to transform A in into a matrix of the form INB produces a row whose first small n entries are zeros. So a long sentence has been written over here. So we can only understand about this particular the statement only if we try to do it by our own hand. Okay, so let us select a matrix of this form, which I'm choosing from question number 5 of page 166. Okay, and the matrix given is 1 2 and 2 4. And you can immediately say that you don't have to perform any rank operation over here. You immediately say that, okay, that A is equal to 4 minus 4, and which is 0. So it implies that A inverse, A is not invertible. A is not invertible. Suppose I want to find A inverse. Okay, I want to find A inverse. I want to perform the operations which I did earlier. Okay, so if I write the matrix in the following manner, because if you are confined in the domain of determinant, then we shall not try to divide by 0. But here I can try, because I'm not going to divide, I'm not going to do any non-mathematical things over here. So I can perform row operations over here. Nobody is actually putting any objection. So my objective is to understand what this line is saying. So suppose I have written in this manner for the given matrix, and in that case, I want to bring identity matrix on the left hand side. So what operations can I perform? So I can keep this element 1, and I want to make this element 0. Okay, so then I have to decide what operations I want to perform. So if I want to make this element 0, then I can keep R1 as same, and I can subtract from R2 twice R1. Okay, so if I multiply both the sides by both the entire row by 2, so we get 2 and 4 over here, and therefore 2 minus 2 gives you 0, and 4 minus 4 gives you 0. And here we are going to get, that is 2, that becomes 2. So 0 minus 2, that is minus 2, and that is, if I multiplied by 2, that is 0. So 1 minus 0, that is 1. So we're getting this. And then if I want to get this 1, I want to make this element 0, then in that case, what can I do? I can do nothing. I can do no row operations over here to make it 0. So what is actually saying that, see, I'm unable to perform any further operations over here, and this matrix is not identity matrix at all. So what is it written over here now? Let's find it out. Then any attempt to transform AIN into a matrix of the form INB produces a row whose first n entries are zeros. So see, will produce a row whose first n two entries are zeros. Okay, so that is happening over here, and that means, and that also you can say that from the left hand side, that you can also say that if this is your A, then we can simply say from here that rank of A has come out to be 1, which is less than 2, and therefore it is quite obvious that the inverse of this, the matrix inverse, is not existing for the given matrix. Okay, now I'm going to ask you to solve one or two problems by yourself. So I'm giving you one problem. Say, for example, first of all, you can check with this 1 2 1 1 3, and what is given 4. Okay, and 2 3 minus 1. So your question is, try to find the inverse, if exists, using rank method. And the operations which I have performed in calculating the rank operation, in calculating the inverse of the matrix, the elementary row operation that we have performed is actually a special case of row reduced echelon form. In some other classes, probably you have seen that the teachers have already done the row reduced echelon form, and probably you are thinking that our teacher is not discussing this, is not uttering this term at all. So you shouldn't blame me. I have uttered this at least for today's class. I shall discuss row reduced echelon form in due time. Don't worry about it. Okay, so give me some time. I am definitely going to say everything to you. We are not going to miss any point. Ultimately, my teachings will be the superset of other people's teaching. No problem. Don't worry. If I have time, then I'll definitely discuss. Okay, so here I am stopping, and you're supposed to find out the inverse. You are going to check whether the rank of this matrix is 3 or not. So you're checking. First of all, you need to check. Check step number 1, rank of A. You can check it. If it is less than n, then you can avoid finding the inverse. Now, if it is equal to the order of the matrix, then step number 2 is you try to convert AI to IB, where I is identity matrix of order 3. Okay, so you try this, and I am just pausing my recording and waiting for your reply. Whatever you get, I'm enabling the chat box so that you can write your reply in over there. Reply. So since in the previous stage you have found that the rank of the given matrix is 2, and if you are correct, then inverse A inverse is actually not existing for the given matrix. So this is our new matrix which you want to play with. First of all, you find rank of this matrix, and then you decide whether the inverse exists or not, and write in the chat box. So I'm waiting for your reply. Someone has written in the chat box that who is Nahsal Manir and Arnab Chakraborty. They have written that they have found the rank of the matrix as 3, and it is all right. Rank of the matrix is indeed 3 because I have already checked this by using the Maple software. So you are correct. Now your job is to, since rank of the matrix is actually 3 and it is same as the order of the matrix, now your job is to take this matrix into consideration. That is 0, -2, 4, 1, 1, -1, 2, 4, -5, and you augment this with the matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, and you try to find out what is its equivalent form given by IB. So you are supposed to find IB from here. Okay, so I am waiting for your reply. So you try to perform row operations on the given matrix. Only keep in mind that you are supposed to apply only row operations and not column operations. Okay. Indranil has written I first. What do you mean by that? I first? Oh, you first. Okay, so you first did it. Okay, so okay. Sorry. So I must take your name. So Indranil first, Aniket Verma, Arnab Chakraborty, Nahsal Manir, Anjali Agarwal, and someone roll number. Many people have said has made this calculation and found the rank of the given matrix as 3. Now you try to find the inverse, and let me check who can make it first. I know that you are facing difficulties in performing row operations. Probably you are facing difficulties in performing row operations and you are confused, and probably you are not getting what you expect to get. So that is, you don't have to be worried, because that is bound to happen, because it happens with everybody. It happened with me also when I was student. It happened with every student who earlier learned this. So this thing is new to you. So you are facing difficulties is a good gesture, because if you are not facing if you are facing difficulties, that means you're performing. If you're not facing difficulties, you are just sitting idle. Okay, so I'll ask you to select matrix from anywhere, any 3 by 3 matrix, anywhere you select the matrix, and try to apply elementary row operation and column operations over there. Here, to find inverse, column operation is prohibited, but if it is a matter of finding rank only, then you can apply both the operations. But if you want to apply the, if you want to find the inverse, then in this manner, in this method, then actually rank operations, column operations is not permitted. And the way, I mean, last week, yeah, okay, someone has got something. No, as per the software, Ayan Banerjee, as per the software's value is not matching as per the software, but software cannot be wrong. I think Android cannot be wrong. So as per the software, the values are not matching. The first row is not matching, second row is not matching, third row is also not matching. If one is not matching, consequently the others will definitely be not matching. Just a minute, someone has written Aniket Verma. Just a minute, Aniket. Just a minute. I hope that you have done it by elementary row and row operations. I believe you. I believe you. So if you have done it, you have done it correct. Okay. So the A inverse is coming out to be, and if you are telling me lie, then it is your problem. You are not learning then. What can I say? It is entirely your problem, not mine. And if you have done it correctly, yeah. Nasal Manir has also got it. No, Nasal Manir has got something. Yeah, same thing. Nasal Manir has also got. So this is your A inverse. And others who are not able to do it properly, then I'm not discouraging you. Take as many problem as you can from different books and try to apply row operations and column operations. First, you be comfortable with finding rank only. Once you are comfortable with finding rank, then what you can do is that you can uh, apply row operations to find matrix inverse. Okay, so that is that needs actually a little bit of practice. So don't worry that others can do and you cannot. You will be able to do it after some time, after some practice. Just don't deviate from the rules I have stated to make the elementary row operations. Now we have some, yeah, okay, so time is 9 minutes, or 9 minutes is remaining. Let me introduce a row reduced echelon form. Row reduced echelon. It is termed as echelon. Some people call it as echelon. Some people say it as echelon. So I am putting this in plate in front of you, and you will decide what to call it. I will call it echelon. Okay. Some people call it row reduced echelon form, and in Friedberg they called it reduced row echelon form. Reduced row echelon form, according to Friedberg. And I think this person is actually very careful to place the name. I'll not go into the debate with other people, but I'm comfortable with this. Maybe you can say that since I like this person very much, so therefore I'm pretty much biased towards him. This reduced row echelon form is nothing new actually. So I am least interested actually about this. And since I'm least interested about reduced row echelon form, so therefore I suddenly, as a punishment, my internet suddenly got disconnected. So actually, I have been punished for this and lost my entire board work. So anyways, the definition goes like this. Okay, a matrix is said to be in reduced row echelon form if the following conditions are satisfied. If the following conditions are satisfied. And in Friedberg, it has been presented very nice way by putting numbers. In some other books you may not find it because it is written in lines, single line. It can also be written in a single line also. A row containing a non-zero entry precedes precedes any row precedes any row in which all entries are zero, if any. This is the first thing. So let us try to understand what do they mean by that. Any row containing a non-zero entry precedes any row in which all entries are zero. So suppose I'm giving you a matrix like this, capital A, and I'm saying that this is my matrix 0 0 1 1. Okay, this matrix is not in, let us call it, reduced row echelon form, RRE form. Okay, in short. So it is not in RRE form. It is not in reduced row echelon form. Why? Any row containing a non-zero entry, any row, this row was containing a non-zero entry, second row was containing a non-zero entry, precedes any row in which all entries are zero. But here you have written the row with zero entry first and the row with non-zero entry second. So therefore it is not in RRE form. What will be the correct version of RRE form? The correct version of RRE form according to this particular rule would be 1100. Okay, that is what meant by point number one. Simple things. Okay. Number two, the first non-zero entry, the first non-zero entry in each row, is the only non-zero entry in its the first non-zero entry in each row is the only non-zero entry in its column, Okay, so let's try to understand what do they mean by that. So let us consider a matrix B, and I'm writing it in this way. This is not RRE form. It is not RRE form. Why it is not in RRE form? The first non-zero entry in each row, the first non-zero entry in each row, this is the first non-zero entry in the first row, is the only entry, is the only non-zero entry in its column, but it is not the only non-zero entry in this column, because in this column another non-zero entry is available. So that is not RRE form. Or if you talk about the first non-zero entry of the second row, then you see it is appearing in the column in which the other entry is also non-zero. So therefore in both the way, this is not the actual RRE form. So what we do to get RRE form, what we can do over here, we can put a elementary row operation, and we can subtract R1 R2 from R1. So you can get 1 minus 1 0 and 1 minus 0 1, and that is 0 1 1 0. This matrix is in its RRE form. This matrix is in RRE form. Okay, and it is satisfying the condition 2. And number 3, the last thing, the first non-zero entry, the first non-zero entry in each row is 1, and it occurs in a column in a column to the right, to the right of the first non-zero entry in the preceding row. Nobody is going to ask you the points discussed over here in reduced row echelon form. Nobody is going to ask you. You just keep this in your mind. Okay, so the first non-zero entry in each row is 1. Here you see the first non-zero entry in this row is 1. And it occurs in a column, it occurs in this column to the right of the first non-zero entry in the preceding row. So it is occurring to the right of that. Okay, so that is also a kind of RRE form. That is the third condition of RRE form. Okay, so the best example of a reduced row echelon matrix, the best example for this is, you can consider that 1 0 0 0 1 0 0 0 1. This identity matrix is the best example of RRE matrix, reduced row echelon matrix. So this only doesn't applicable to, I mean, this is not only applicable to square matrix, it is also applicable to rectangular matrix also. So for example, if I take a matrix like this, then also it is in RRE form. Okay, so why this reduced row echelon form is needed? Reduced row echelon form